wow, everything that happened before was just, history, and now the history starts from today. Maybe it's true, maybe not, but nevertheless, we should be very specific from now, really, and serious on who we are. And in your presentation, I understand you want to divide us into two parts of companies. Those who know that time to time someone coming, knocking on his door, and those who don't know that there is a data protection vulnerability coming. So should we vote who we are? If we are serious companies here, the ones who understand that time to time there is data theft in your systems? Yeah, you do. Okay, so no second-class people. Okay. Everyone agrees that it is very serious of what you are talking about. Okay. How to make these our nice firewall and other niceties in real work for 24 hours, but actually for good being of Gdpr. Everyone knows what is Gdpr from nowadays.
Okay, thank you very much. Just to introduce myself, my name's Adrian Winckles. I'm the cyber lead at Anglia Ruskin University in Cambridge in the UK. I'm also the OWASP Cambridge chapter leader. Title of my talk today, no GDPR worries here, I've got a firewall. In other words, the need for secure coding. A few little bits and pieces about myself. One thing, I probably wear too many hats, but I'll let people decide that afterwards. One of the things I'm talking about is we have the old adage. There are those that know those have been hacked and those that don't. And that continues to ring true. We tend to put all our trust in layers and layers of hardware protection for our infrastructure. In other words, we've got a firewall, so we must be okay. We can tick the PCI DSS box when we self-declare that we are certified for credit card transactions. We can tick all those boxes. The trouble is, we tend to have to be lucky all the time where data breaches are concerned. Our enemy only has to be lucky once. What is it that we've forgotten? What is it that we need to redress so that we are lucky all the time? So as I said before, we've got layers and layers of infrastructure. I've got a firewall, so therefore I'm not going to have a data breach. Famous last words. But we've also got things like intrusion detection, intrusion prevention. We've got endpoint protection, security incident and event management systems. We've got VPNs, we've got antivirus, we've got back-end encryption, we put SSL, TLS on everything, and we still have problems. One of the issues that we have is we've done infrastructure protection to death almost, but we still have data breaches. What we tend to do is we put layers and layers, because I like to think about security or infrastructure for security being a bit like Swiss cheese. Anyone else about Swiss cheese? It has holes in it. So to cover the holes, you have to have multiple layers. But we still have data breaches. Some people say to me, it's about 0 days, isn't it? We all know what a 0 day is. We're all technical. We know that there are vulnerabilities out there that haven't been patched. So there's a bit of information about knowing what we don't know. But that's not the end of the story. So where are the problems? We said it's not just about infrastructure layers. It's not just about the operating system. It's not just about what's known. And it's not just about what's not known. Some of it's about what we've already got. Poor cyber hygiene. There's one thing we're still forgetting, especially when we're coming up to thinking about how we protect our data for GDPR. Have we thought about the application? Have we thought about the software we're running? Let me explain a bit further. It's not just my word for it. People like Gartner are saying that 75% of security breaches now happen at the application. So while we've been concentrating on the infrastructure for all these years, we keep forgetting about the bits of code that we write, that we put on our web applications. Gartner also say 70% of security vulnerabilities exist at the application layer, not at the network layer. It gets worse. If only 50% of software vulnerabilities were fixed prior to production, data breaches could be reduced by 75%. It's not just Gartner saying this. The National Institute of Science and Technology in the States are also saying 92% of reported vulnerabilities are now in the application, not in the network. So it's the application that now carries most of the risk. And from a developer's point of view, it's costly to fix vulnerabilities once they're out in the field. The time to fix vulnerabilities is during development, during the testing cycles, not when you've deployed the application. There are some very interesting statistics that Synoptic have just released that talk about for every dollar spent in debugging security issues during the development phase, you could save up to $100 when it's out of production. If you use the NIST statistics, you can actually see that most of the vulnerabilities are now in application or application-related part of the stack, not in the infrastructure. One of the adages is that if cars were built like applications, 75% of all cars were built without engine designs and without blueprints. The other 30% would have no designs at all. Cars would have no airbags, rear view mirrors, side mirrors. They would have at least a cup holder for 6 cups. Not all the components will be bolted together securely. Safety tools would only cover front impact only, and so on. We don't treat security seriously in our applications. Applications are the big issue. Again, don't just take my word for it. Does anyone recognize some of the vulnerabilities along the bottom here? Anyone recognize this one? Heartbleed. And what was Heartbleed? Vulnerability-wise, do you know?
Be straight and loud.
Implementation flaw.
Implementation flaw? It was a vulnerability in an open SSL library. So if you were using something like Apache for your web application, then you were probably using Open SSL because you wanted a secure sockets layer, you wanted a secure e-commerce application. The flaw was built into the library that hundreds of thousands of deployments of Apache were using. Struts, heard of struts? Issue with struts. Maven Central's repository had critical flaws in it. What about the one to the right here? Anyone know what this one is? Sorry? Close. Xcode. Xcode, any iOS developers? No? So if anyone developed iOS apps for Apple tablets or iPhones, iPads, there was a group of Chinese developers that thought it was rather nice to have a free version of Xcode. And of course, Xcode is a royalty-based Apple environment. Someone made a free version available for download outside the App Store. But of course, that free version essentially had vulnerabilities built in. It had a malware kit built into it. So several thousand trusted Apple iPad, iPhone applications had to be fooled because you had vulnerabilities built into it. So what I'm saying is, in the trend to deploy applications to end devices, we can easily build in vulnerabilities by the use of shared libraries, shared code. That's why applications are the big issue, because we rely and we trust lots of other code that we borrow from other people. So one of the common adages is, oh, we can sort all our compliance needs out by just having a pen test. If we do a pen test a couple of times a year, that'll test our applications, that'll test our infrastructure. How many times can you afford to do a pen test a year? Once, twice a year? What's the problem with that? We're approaching the problem completely wrong. We've been doing it for years. There's too many variables to rely on someone externally to apply a black box testing approach to just essentially test everything externally for a week, twice a year. The problem's something like this. We heard the expression, the tip of the iceberg. The pen test does the top of the iceberg, but underneath there are many man-years of development into things like logic flaws, code flaws, security errors. A pen test cannot address them. This diagram sort of puts it in a bit more perspective. Remember, the attacker only has to be lucky once. Attacks can be automated, they can be replayed and replayed. Your pen test, once, twice a year. The attacker's continually probing. Pen tests are an essential part of your overall security and GDPR strategy, but they only go so far. You have to think about other things. Here's part of the problem. We deploy web applications as part of our front-end e-commerce solution, part of our electronic shop, part of our software as a service. The problem is, we put our layered products, I said about the firewall at the start, we let the application through the firewall. The applications, the access is coming in on port 80, we allow it through. We allow it through the back end into our database. The application is trusted. That's part of the problem. The other problem is one of education. We have a gap between our security specialists and our developers. Security specialists know about some of the threats, they know about the infrastructure, but they don't know about the application. Developers, QA professionals know about the application, but they don't really know about the security they should be building in. So what do? We need to think of applications in terms of vulnerabilities. Applications are going to have vulnerabilities in them, and they need to be tested from a security point of view, like everything else we do with applications, user experience, unit tests. Security should be part of that whole experience. What I like to think of, Weinberg's second law sort of sums it up very quite nicely. If builders built buildings the way that engineers wrote programs, the first woodpecker that came along would end civilization. So, what do we do about fixing this problem? From a security analyst point of view, they need to understand the data, the information held on the application. They need to understand the types of users is half the battle. And they need to involve developers and analysts together right at the design phase. Developers need to understand and embrace secure application development. If you think about the OWASP top 10, and everyone's familiar with the OWASP top 10? I think there was a speaker this morning on OWASP top 10. What's number one in the OWASP top 10? Anyone remember? Injection attacks. Injection attacks have been number one since the OWASP top 10 has been in existence. The SQL injection, which is the main vulnerability that allows attackers to take contents of databases, sometimes credit card data, and usually most large data breaches involve some issue of SQL injection. Not the only issue, but one of them. SQL injection is easily fixed. Things like input validation, parameterization of input data can help solve the problem, but developers need to be taught that. Security needs to be built into the development frameworks. Quality should mean not just that it works, but quality should include security as well. QA testers, security vulnerabilities should be considered bugs. Essentially, the same way that you have a functional bug, and it should be tracked in the same manner. It's important for managers to become involved as well. Factor in to project plan security. Security is everyone's responsibility. Security is an added value for an application. Here we are, $1 spent up front saves $10 during development, $100 during release. So we need to think of this in terms of a bottom-up and a top-down approach. From a bottom-up approach, developers don't have time to test adequately, if at all. Developers don't really know about secure coding practices. There's a huge demand for businesses to be first to market, and that's essential, but you should build in security at the same time. And one of the largest problems we have is we tend to use what I call COTS devices, or customized off-the-shelf code that hasn't been validated, hasn't been tested. It's code that works, everyone else is using it, so I should as well. So how do we deal with that with developers? It's about education. Not all developers go through the standard route of university, getting a computer science degree, and then starting as a coder. Some come from different routes, so there's a need to educate existing developers and new developers coming into development teams on secure coding practices. Testing should not just consider functionality, but security built in from first principles. Sanitize third-party products and libraries. And testing throughout the software development lifecycle, not just at the end. There's also a top-down problem as well. So I'm not just going to blame developers. The pressure to be first to market often means security is a secondary consideration. Cost reduction removes security testing. Also, security is often not seen as a boardroom priority, which is something that needs to change. And organizations often have a lack of a security culture. So how do we solve that? Again, education. Educating the boardroom and senior management that security needs to be built in from the start. And this can be very much about representation. There should be a CISO on the board. GDPR has necessitated that organizations consider data protection and users' personal data seriously. The fines that can be levied are now 4% of gross international turnover. So therefore, GDPR should bring security to be a boardroom issue. And who's going to represent GDPR on the board? As I said before, security is everyone's responsibility. Organizations should have a security culture. So it's about bottom up and top down. It's about building security in. There has to be an equilibrium between developers and the board. If you're going to deploy applications in your network, then you need to have the appropriate applications tested from the ground up. And that has to be everyone's responsibility. So it's a need for education. Educating users, security awareness programs, educating developers. In the UK, some of our professional bodies have adapted university curriculums to include secure coding for the first time. The British Computer Society, ISC Squared, OWASP have all come together to actually say we need security built in to our educational programs. We need secure coding to be there in year one. In some cases, at further education, as soon as people start leaving school, and why not whilst they're at school? Education doesn't just stop if you're at school or if you're at university. You need to keep selling that message. Essentially, the testers, the board, the developers, the security analysts, the threats change, but the message should stay the same. Who can help? OWASP, the Open Web Application Security Project, we've already mentioned the top 10. There's also a whole load of free open source material, things like cheat sheets, OWASP testing framework, the secure software development guides. All of those sort of applications are free of charge, can be incorporated in organisations' own training materials or your preferred training provider. There's also a quick developer's guide which provides links to the material. I'm happy to go over with anyone if anyone wants where materials can be found. Thank you very much. Any questions?
Can I use this opportunity of round of applause just to give you this certificate of being here? And the date of today, I think, is the most important value of this. It's a kind of new era, as we feel sometimes, I think. Digital era is also the name of this conference here. So any suggestions, questions? Yes, please.
Just to a little bit explain, what is missing? In a sense, you in so many ways said that we kind of understand the issue. We all know that there is a problem, that the cost is too high, and then there is an issue that nobody cares. So what is actually the problem? In my understanding, it didn't reach the place where you said that here is the essential problem to solve.
I think the problem is that we still put too much faith in other people to solve our security problems. Because a lot of the developers and testers still think it's being pen tested at the end, we're black box testing, we'll pick the issues up there. Yes, some issues may be picked up there, but it's going to cost you so much more. And you're not going to pick up all issues with 2 pen tests a year, which is what typically most organisations actually. What I'm trying to advocate is that we should be, via education, via other methods, ensuring that we are building in security into all our software. If you think about IoT, I think IoT is always the classic example, that I tried to preach this message at an IoT conference 6 months ago. Afterwards, I went round every single IoT developer at IoT Expo in London. Out of the 30 stalls, no one wanted to know about security. I've got a need, my product needs to be first to market. I'll fix security later on. It's not an issue. That's really
so
what I'm...
Do you have a good example where you would say that a company was well enough punished for becoming first on the market with a crappy solution, but that did actually serve the end customer from the functionality point of view, had a poor security, but later on that was the thing that they actually were punished for, that there wasn't enough security?
And do you have it? Can you name this company like this?
No,
okay, so can you?
No, at the moment, this is where possibly where GDPR comes in. Because until now, there hasn't been very much of a stick. Organisations have lost reputation. Some organisations have gone out of business. But knowing that in your supply chain, if you've supplied products that haven't been tested, if you're going to lose 4% of global turnover because you supplied a product that wasn't fit for purpose, then potentially you could be putting your reputation or your customer's reputation at risk. So it's the risk at the moment that hasn't really been addressed. But there's been a lot of damage to reputation, damage to turnover, but not, there hasn't been a big enough stick yet to deal with the issue. That's the problem.
Well, if we at least now understand that this regulation, the new regulation, GDPR, is a stick, maybe the next speaker will find it as a carrot. No? Would it be a carrot instead of a stick? We'll see. Anyway, thank you very much. Thank you.